So this time we're going to decide whether a function is even, odd, or neither. In the tutorial for this, basically I point out for sure that this even odd scenario doesn't create two categories of functions, it creates three categories of functions. Basically, even and odd are talking about symmetry. So quickly, an even function is symmetric with respect to the y-axis. An odd function is symmetric with respect to transformations of the y-axis and then the x-axis, which they usually say the origin in the books, which is fairly vague, and I'm sure you didn't understand what they meant the first time. We'll go over that once we show a little bit. But there's a third category. Some functions don't have symmetry with respect to the y-axis or the origin, so they are neither even nor odd. We're going to find out in a second why they called them even or odd. In particular, this one's going to be odd. Why is that? Look at the exponents. So the definition of why I do this is going to be, I put negative x where x was. If I can spit out a negative on the function, it's an odd function. If f eats the negative, it becomes an even function. Even functions are the gluttons. Odd functions are the bulimics. They spit it out. Gluttons eat everything. So let's find out which one it is. Or you could be neither. So the first thing I do every time I do even and odd functions is I put this is the first thing you should see. If you're not doing this and you're trying to argue, I know you're not doing it right, because the definition says I have to look at negative x. That gives me negative x to the 5 plus negative x to the 3 minus 7 times negative x. Now, because these are all odd exponents, I can pull a negative out of each one of those, so that gives me negative x to the 5 minus x cubed plus 7x. And now the plus, I did that on purpose because there was two negatives, but that's possibly where you might have wanted to keep that. It's minus 7 times negative x, because what I want to see is I have a negative that I can pull out of every term. I'm going to do that. So that equals negative x to the 5 plus x3 minus 7x. I pulled this negative out, this negative, and this negative, and there it is. But what is this? That's my original function, negative f of x. So f is odd by definition. F of negative x equals negative f of x. So this function is odd. In particular, it's odd because all the powers are odd. That's one way we can tell.